And we are live. Hello and welcome everyone to another workshop here with Mode. Today we have a very special guest, as always, in these amazing workshops. We have Valentina from Chainlink, CRX Bonds as well. Hey, Valentina, how are you?
Hello, I'm doing great. Thanks for having me.
No, thank you for being here. Do you want to tell us a little bit about yourself? What do you do at Chainlink? And also, what is Chainlink? A little brief intro.
Yeah, so about myself, my name is Valentina, and I am a developer relations engineer or DRE at Chainlink Labs. And I also have experience as a full stack engineer with experience from smart contract development in Solidity, machine learning in Python, web development in TypeScript, and building vanilla JavaScript backends, etc. And and the other question is, what is Chainlink? Is that what it is?
Yeah, you just dropped
Yeah,
us a lot of experience right there, like in
yeah.
one
I
line. That's
dabble.
impressive.
Yeah,
That's awesome. And yeah,
you know,
I would like to know your definition of Chainlink. So, what is
yeah.
Chainlink?
Chainlink is a very useful technology that enables all developers to have access to adding superpowers to blockchains. So blockchains ordinarily they exist in silos, which means that they're not able to access information that exists external to that blockchain. So since it's just a ledger, you just have transactional information that's only contained in that blockchain. So where Chainlink comes into play is if you're trying to get information, like let's say that you have a predictions market and you're trying to predict the outcome of a presidential election. Well,
Mhm.
you can feed into the contract any answer you want, but most people are not going to trust just any answer being pushed into the contract. They're going to want to have a verifiably useful and true, valid response, right? One that has a mechanism that enables there to be a sort of system that comes into play that validates and verifies the information that's being passed into that contract. So this is where Chainlink comes into play with the Chainlink Dons or the decentralized Oracle network, which allows for us to facilitate this sort of relaying between off-chain information on chain. And because of that ability, with you leveraging that Dawn technology, the decentralized Oracle network, you're able to do a lot of magical things like functions where you can get API calls and use that external API call to bring in information on chain. I've done a workshop before, for example, using AI, so using OpenAI to get a prompt response and then feeding that back to a smart contract. And function enables you to do that. Everybody knows about oracles, Chainlink oracles, the biggest in the market. The oracles are useful for prices. For example, so you can get the price, and that enables like lending markets to be able to be used in a way that is not easily manipulated. And also, of course, as we're going to be speaking about today, we have CCIP, which allows for us to facilitate cross-chain communication. And it's very interesting, especially looking into how CCIP can correlate to some of the technologies that happened at the very beginning of the internet. So now we're starting to use the same sort of protocol to use a technology that allows us to have blockchains that used to be nascent silos to be able to communicate with one another, even if they aren't natively compatible.
You're gonna leave me without words. That was an amazing definition, not only about what Chainlink is, but also the problem that you guys are solving. And I love it, loved it. Bringing off-chain information on-chain in a reliable way. It's not an easy task, or it wasn't as easy. Right now, we're a little bit more used to it since we've grown as an industry. But it's always important to remember that trusting those numbers, trusting those price feeds, trusting all that information that's coming off chain. It's a complex problem to solve. And with CCIP that we're going to see today, I don't know if you know, but we just finished the Super Hack, which was a hackathon with Optimism. I think you guys participated as well, and a few other amazing partners. And a few teams were building with CCIP, and leveraging this thing that you're mentioning of like breaking the silos and communicating between chains and between this ecosystem that used not to be being able to communicate. A lot of apps now are going cross chain, and I love to see that. And they can build a cross chain app in like less than 2 weeks, which is
Yeah.
pretty impressive to see. So that's what we're gonna be seeing today and analyzing things that the builders can build, some use cases, potential use cases as well. And yeah, just getting and diving deep into CCIP. Now, I'll stop bothering you with questions right now, Valentina. I'm really excited to see the workshop you've prepared for us, and thank you for being here. And yeah, the stage is all yours now.
Well, thank you so much. I appreciate that and appreciate the introduction. So yeah, I'm going to hop right on into it. So we're going to start off with which looks like we've been a little bit ahead there. But thank you all for joining us today. And as you may have already guessed, we're going to be discussing Chainlink CCIP on Mode. And CCIP ultimately empowers Mode to become an even more robust platform for cross-chain interactions. And today, what we're going to cover is how we can use a cross-chain solution, how it's designed, and how we can then use it to have a hands-on application that can demonstrate how CCIP can work and work for you as a developer. So I already did my introduction earlier. My name is Valentina Alexander. If you're interested in following me, I have some of my links there. I have my YouTube and my X account or Twitter. I still refuse to call it X, so call it Twitter. And it's at 0xbuns. So you can find me there. Also, of course, on GitHub at bunsdev. At the time of me making it, they didn't let you do 0x's, but now they do apparently. So let's move on. So let's look into our interoperability problem. And that way we can discuss, before we get into the solution, we can discuss the problem that we're trying to solve in the first place. So Chainlink is very solutions oriented. And as you can see here, there is a problem with interoperability, and that is the lack thereof. So interoperability is just defined loosely as the ability to share data across blockchain networks or networks in general. And this is even whenever they are incompatible, as I was saying earlier today. So recall, as I said earlier, that the blockchains, they operate independently of one another. So they exist in their own little silos and they're isolated from one another. But the benefit of having these interoperability protocols, it allows for you to bridge and therefore have and leverage interoperability by providing an infrastructure and a mechanism that helps with facilitating cross-chain communication. So as you can see in this diagram, so built beautifully illustrating how you can have a block and another block and another block that's also communicating with an entirely new set of blocks. And as we discussed earlier briefly, there is a difference between a one blockchain and another blockchain. That's a number of ways that they're distinct from one another. They can have different block times. They can have finality rules that are distinct from one another, different mining mechanisms. They can have different costs associated with transaction fees, et cetera. So they're entirely different sets of blocks that exist on a blockchain. So you go to Ethereum, we look at what they have there. You go to Modu, look at what they have there. There's a different number of blocks, a different process, everything. So ordinarily, you wouldn't be able to just relay information from one blockchain to another. You need to have some sort of external agent that's able to come in and resolve that. And that's precisely what CCIP aims to do. So Chainlink's cross-chain interoperability protocol is what CCIP stands for. And what it does is it enables secure and reliable communication between distinct blockchain networks. So it facilitates the transfer of data and tokens across blockchains, and it enhances interoperability and expands the functionality of decentralized applications, kind of allowing for developers to have superpowers. Because developers are able to build applications that can leverage multiple blockchains in a way that's designed to be seamless. And if it's not, then let us know so that we can improve upon it. Constantly improving and building. And we love your suggestions and recommendations. So give it to us. This is a new product and we're very excited to introduce this. And we kind of sat on it for a little while because we really wanted to make sure that whenever we did roll it out, that we rolled it out in a way that was very secure and that was able to access all the functionalities you might see in some of the other options that are out there, but in a way that's able to solve the problem in the most optimal manner. So CCIP enables Mode and other blockchains to serve as a robust platform for cross-chain interactions, and also further enables additional capabilities for DeFi and other blockchain-based solutions. So ultimately, there are three main functionalities that you're able to do with our CCIP service or product. That is first and foremost the ability to transfer tokens. So your standard ERC20 token, like USDC, DAI, Link, etc. These sorts of tokens, you're able to send that from one blockchain to another. We have a bunch of tokens that we've registered that are able to do this through our contracts. So you can check that out in our documentation as well. We also have the ability to send arbitrary data, i.e. bytes, to a receiving contract. And arbitrary data just means basically a message. And finally, have the ability to transfer tokens along with instructions on what to do with those tokens to a receiving contract. And that's what we refer to as programmable programmable token transfers, which we'll get into whenever we cover our live coding session. So what we have here is a very nicely illustrated animated diagram. And this diagram is designed to highlight the core architecture of our cross-chain solution. So if we can dive into this a little bit closer, you'll see that there's quite a bit going on there. First and foremost, we have on the far left side the end user and what happens on that side. We're going to break it down in a second. Each of these different components, there's three of them. We have the user on the source blockchain on the left side. It goes to the CCIP in the middle, and then it ends on the a destination chain with our end user on that end. So let's take a look at the first component, and that's looking at the source chain and what happens there with the source chain. So on the source blockchain on the far left, we have the end user that sends a transaction to a sender. But before we can submit this transaction, we have to, of course, prepare the transaction according to the required parameters that we need for that transaction to go through, which we'll review whenever we go through the smart contract in our live coding session. But ultimately, we must also acquire the fee that we need to pay CCIP, which is where we use a selector chain ID, which is tied to the destination chain. We also use a message and the tokens that we want to send over cross chain. We get all that information. And we can send that data to a data and the tokens as well to a router contract, as you see in the diagram. And those router contracts are what send this information off chain to the CCIP. It's sort of like a black box that does all the processing for us off chain. And these instructions are received by CCIP from that sender through the router. So whenever you're sending, the router actually validates that message that's being sent, and then it transfers the fees to the on-ramp, and it manages, which also manages the token pool. So let's say that you're sending over a token from a source blockchain. Well, you're going to want to need to have the tokens either burnt or locked into a smart contract, which is what happens there. And then that is on the other side, you'll see what happens whenever you're trying to get those tokens on the other end if you're transferring tokens over. So ultimately, you have a dawn, which is going to be in the next section, which is triggered through a process that looks for an event from that on ramp, and that will handle the generated message and that it returns back to that returns to the sender. So let's go ahead and look at what that committing dawn looks like, and that's here in the middle where we have CCIP, we have the committing dawn there, and that committing dawn does some of the risk management that we were discussing earlier. So the committing dawn is Chainlink uh, CCIP's component. We have the committing and the executing dawn. And the committing dawn nodes, they listen for the events, the messages that are ready to be sent cross chain. And whenever they're triggered, they can either be triggered by the time or the number of messages that are queued on the on ramp. It just depends. And the dawn creates a report with the commitment of all the messages that are ready to be sent in a batch. And this is stored as a Merkle root. So it's getting really technical. So bear with me if you don't understand entirely what that means. You don't really need to know every single step of this, but if you want to replay this later, go ahead and do so. It's after that, what we have is a consensus. Upon consensus, the report containing the Merkle root is transmitted to the commit store contract, which is on the destination chain. So the risk management network essentially blesses the Merkle root in the commit store, and it ensures that there's a correct representation of the queued messages at the on ramp. And then the other layer we have is the executing dawn, which is similar to the committing dawn, but it listens to the events of messages that are ready to be sent. It also monitors the commit store to ensure that messages are ready to be executed on the destination chain, i.e., it waits to ensure the messages are included in a blessed on-chain commitment from the commitment dawn. So if the conditions are met, the executing dawn creates a report with all the messages that are ready to be sent, and it sends those in a batch. And the report accounts for the gas limit of each message and its batching logic as well. So it's already able to calculate those things. And the report also calculates a relevant Merkle proof for each message to prove that the message included in the Merkle root submitted by the committing dawn is in the commit store. So note that the executing dawn batches can be any subset of committing dawn batches. And upon consensus, the report is transmitted to the off ramp, as you can see on the right side, contract on the destination chain. And this off ramp will do one of two things. So the off ramp, you can see right here. So the off ramp is able to either mint or see, the off chain is able to either mint or transfer over those or unlock rather those tokens. So we have lock and burn on one side, and we have unlock or mint on the other side. So upon consensus, it's able to do that with the token pool, and whenever it's executing that information through the off ramp, if their tokens are included as well, it'll make sure that those tokens are sent over to the router. And so on the source chain, the off ramp pulls unlock or mints function, which validates the token pull rate and then unlocks to the other side. And then it sends it over to the receiver. The receiver can either be an EOA or it can be a contract, a smart contract. So ultimately, in summary, the way that it breaks down is that you start with the end user, sends over this information, and it does so through a router, which uses an on-ramp to either lock or burn the tokens. Then the on-ramp sends the data and or tokens to CCIP, which processes the transfer off-chain and returns the resulting instructions to an off-ramp, which either unlocks or mints tokens in the token pool of the destination chain. Then a router passes along the desired data and or tokens to a receiver and or an end user on the destination chain. So that's the whole process. I know it's a lot, again, to consume, but out of interest of time, we're going to close this up by just saying that ultimately CCIP enables blockchain developers to leverage a single universal message interface to build cross-chain applications and offloads complexity of chain-specific interfaces, transport layers, validators, and node operators so that you're able to just get down to business and you're able to very quickly and easily connect your blockchain to another blockchain so you can do some blockchain magic. So what we're going to get into now is the next element, which is the live coding session. And while we transition into there, do you see any questions or do you have any questions before I open that part up?
I don't see any, but I do have one for you.
Okay.
Glad that you asked. So you mentioned the lock and lock model and burn and mint model as well. Can
Yes.
you do both with Chainlink CCIP? And what would you recommend, or like, how do I choose which one to use? Yeah, that's a question.
So there may be some tokens that you don't want to burn. Maybe you don't have access to being able to use a burn functionality. So certain ERC20s aren't burnable. There's only a certain extension of the loss rate burnability, for example. So that'd be a little bit problematic. There are also some tokens that don't allow for you to mint tokens, or they have a limit on the sort of minting functionality, or maybe you don't want to pass in the minting functionality to a contract. So instead, you just allow for that there to be a pool that you could transfer into the pool and then allow for the pool to unlock those tokens as they're received on the destination chain and lock as they're sent over into the source chain. Does that make sense?
Totally. So
So it depends on
depending
your
on
use
the
case.
asset that, yeah,
The asset, yes.
awesome. Thanks for the answer. We can
Yeah.
see your screen now. Yeah.
Oh no, no, kidding. Well, good. I was hoping that you could see my screen. Alrighty, so let's see. We got a lot of stuff going on in here, but we're going to work together and demonstrate how we can use 3 different examples to help with facilitating this CCIP service. And I'm looking at my timing notes and I'm exactly on time. So cool. Cool story. So we're going to work through 3 examples. The first one is going to be transferring tokens from Mode to Ethereum's Sepolia testnets. And then we're going to send and receive cross-chain messages. And then the third instance is going to be a programmable token transfer, which will allow for us to trigger complex actions upon the arrival of these tokens. And this is going to allow for the target blockchain network to get a token that has actions that are tied to that token being received as well. So before we get into this, if you're wondering what's on the screen, you can go to the GitHub repository that's made public at github.com/bunsdev. That's BUNSDEV/CCIP mode. I'll copy that over for you so that you could put that in the chat. Are you able to do that on your end?
Yep. Can you send me the link somewhere?
I'll put it right here. I'll do it in our private chat.
Yeah, great. Let's do that.
All right.
Perfect.
And then what we're going to do is once you have that ready and you've worked it, just make sure that you prepare your coding environments, and you can do that by following along with the README that you can see here on the screen. You'll see the Get Started section, and in the Get Started section, there's a few steps that you will have to do in order to make sure that you're able to be completely ready. So of course, you're going to have Foundry, you're going to have Yarn. It's assuming that you already have these things, you already done the Foundry up, et cetera. You have it all running. And if you don't have that, then you just do that after the stream because it's probably going to distract you for most of the stream if you're trying to do that live with us right now. So once you have all of that set up, what you're going to do first and foremost is install the dependencies. You'll use the command yarn and make, and that's going to use the make file and go ahead and get you all set up with Foundry. And then after you prepare the Foundry packages, you can continue with the next step, which is the setup of the environment variables. So you're just going to copy and paste the env.example and name it .env. So you can just do that in your terminal by doing cp.env.example space .env. That's just going to copy over the .env.example into your .env. And if you're wondering what .env is, that's just where you can store your private environment variables in a way that is private. Just make sure that your get ignore remains to keeps the .env in there so that you don't accidentally submit it to GitHub, because trust me, your funds will be wiped out sooner than you notice that it was sent there. So be very careful with that. It's very important that you keep that information secure. Now, once you've copied it over, go ahead and fill out that .env with the associated variables that are there, with the exception of the deployed contracts, because of course you have not yet deployed those contracts. And after you've done that, then what you're going to want to do is you will do source.env, and that will just make sure that you have it all set up there. You will also need to have some testnet tokens. So this is a absolute necessity for continuing on with the rest of the tutorial. So fortunately, we can make this very easy by using Chainlink. Chainlink has a testnet faucet that's easily accessible. That's chain.link/faucets. If you need me to type that in chat, I can as well, but it's chain.link/faucets. And there you can click on a button that says get tokens and then select the tokens ETH and Link, and you get those for both networks that you're going to be connecting to. So now that you've installed your dependencies, you've acquired your testnet tokens, you've set up your environment variables, you're ready for the next section, which is, as you see here, the setting up of these scenarios. So we have the setup of the setup. Now we have the setup of the scenarios. So with the setup of the scenarios, what will happen there is a few things, but before we move on to that setup, if you do feel like there's a lot going on right now and you feel a little bit overwhelmed, and you'll be somewhat fast-paced because there's a lot that we're covering today, just feel free to take some notes, get a drink, get a snack, relax, enjoy what you're listening to. It's going to take some time to grasp things, and you're not going to become an expert in an hour, so don't expect yourself to become an expert in an hour. This stream will be recorded, fortunately, so you can go back and you can replay any of these sections as you need. So, all right, now let's proceed with the rest of it. Recall the diagram that we looked at in our presentation earlier. At a high level, we had the senders and we had the receivers. So we have the senders on the source chain, the receivers on the destination chain. And what we want to do with those senders is we can either have those senders be a smart contract or an EOA. EOA just being a user like you or me, or a smart contract is something distinct because it's actually able to do programmatic responses to either sending or receiving these sorts of tokens. It's a little bit more sophisticated way of dealing with these transfers. So we'll use, in our case, smart contracts to demonstrate how to send and receive tokens, messages as well, and also those programmable token transfers. And that's what we're going to be covering today. So we're going to deploy the following contracts. And this is going to be referred to as our basic versions of these tokens. As you can see here, we have the basic token sender, the basic message sender, basic message receiver, and the programmable token transfers. So just because I say basic doesn't mean it's easy to understand. There's a lot of things going on under the hood there. So we can take a look at them. For example, we can take a look at the basic token sender contract here, there. So here in the basic token sender, as you can see here, there's a warning. These are hard-coded values. It's not production. So of course, audit your own code. But you have here the basic token sender. It's withdrawal, which means that you're actually able to withdraw from the token. And this is inherited from a contract as well as all these other aspects of it. We have the Chainlink contracts repository that we're using to reference a lot of these, especially namely like the client for CCIP and the iRouter client as well. So this can help us with interfacing and creating the necessary tooling that we need for deploying and leveraging the functions that are inherent in these contracts. So we can have that get supported functionality, which is pretty simple. It's just basically getting out the tokens that are supported by the router. As I said earlier, you can't transfer any and every token. There are some tokens you can't, some that you can. So that's where we can do is by looking at the whitelist. Here we have a send function, which is getting that destination chain selector, which is found in docs at docs.chain.link. and our receiver, and we'll also be passing in the details and what we want to pay our fees in. So we can pay our fees in either ETH or in Link. So that's where we'll specify that there. It's just an enum that says that it's either 0, which is for Ethereum in this case, or 1, which is Link in our case. So if it is one token or the other, if it's just the first option, then we will have a safe transfer for the token that we want to send. Otherwise, we'll do an approval for the router and we'll send it there. Let's see, we create a message, and that's the message that's going to be sent over whenever we're transacting. There's a fee, as I said before in the slides. We got to get some information from our router before we submit our transaction. And one of those key pieces of information is, of course, calculating the fee. And once we do that, then we're able to submit over that message. So that's an example of the sort of workflow that we use. We need to get some information from our router. We got to pass in the router address, pass in our link address, make sure that it's also the router that's associated with the router and the link address that's associated with the source or destination chain, depending on what activity you're trying to do or execute. So we're going to get into some details with that. Now let's look at the first element of this process, and that is the ability to acquire your testnet tokens from the faucet. So these are distinct from getting your testnet tokens from the testnet faucets that we have in from the UI, because those testnet functions are just getting the Ethereum and the link that you need for paying out the fees. But in this case, whenever we're looking at the testnet tokens from the faucet, we're actually talking about the CCIP BNM and the CCIP LNM, which is what you'll use whenever you're transacting on an Ethereum network. So this calls a drip function on the faucet. And you can see here there's a script that we use, and that script is very useful for taking advantage of the faucet script that we have. So before we get into the faucet script, let's just quickly look at what that faucet script looks like before we call it. So here in the faucet script, what we have is a faucet that is able to take advantage of the script functionality that's inherent in Foundry. So with the scripts, you can do some DeFi magic, or some magic rather, with the blockchain magic rather, with the contracts, because it allows for you to use a smart contract to interact with these smart contracts that you've deployed or plan to deploy. I've helped twice, but we'll ignore that. Here, what we'll do is we get the network, and that network is what's passed in through the run function there. And let me go ahead and zoom into this just in case it's too small for people. That happens sometimes. So the run function allows for us to check and see if it is Ethereum that we're specifying for the faucet. If it is, then what we'll do is pass in the network as is Ethereum. It's going to be Ethereum Sepolia if it is Ethereum, otherwise mode Sepolia. And then we'll get the private key, which is stored in our environment variables, passed in there safely. It starts the broadcast, which is what we need whenever we're executing a script. We have the start broadcast, which is called from the VM, which is from the Forge scripts, which a library which allows for us to use some of these neat functionalities. We get over the sender address from the private key that we passed in. We get the dummy tokens from the network, and that is just called from the helper contract, which is telling us the address for the CCIP BNM and the CCIP LNM, and then it'll drip out the CCIP BNM for both networks. And if it's Ethereum, it'll also give you the CCIP LNM. So that's how the faucet works. Just an example again of how Forge uses scripts. It's very neat and very useful. And what we'll do in this case, we have the scripts, Forge scripts, and this is specifying, pardon me, this is specifying, no, it's smaller, or bigger. This is specifying that we're going to be using the faucet script. We're going to get this level of specificity whenever we're looking at the returns. We're going to go ahead and broadcast that onto the blockchain. And since we are broadcasting it on a blockchain, we're going to pass an RPC URL. In our case, you're going to be using mode Sepolia, which is very nice to use. So I have here what happens whenever you do this transaction. You will use that script to execute it like I did here. It'll show you that the script was ran successfully, tells you the chain ID, the gas price, total estimated gas that will be used, as well as the estimated amount that is required to pay for this transaction. It'll submit the transaction, show you the hash, the block, and the paid amounts. And then once it's successfully computed, you'll see it here and where it says total paid, and it'll give you some of the information about where it was sent out. So that is just showing you what happens whenever you run the faucet transaction. And after you have the faucet nice and ready for you, what we'll do is we'll move on to the next step, which is looking at the loading the contract rather with the test token. So after you've acquired the testnet tokens, you're going to proceed with funding your message sender and also your programmable token contracts. And what you'll do in order to do that is you will go ahead and you'll run the function cast send, and you'll use the RPC URL and you'll send to the address that you're trying to send it to. You'll pass in the RPC URL for Mode Sepolia and the value of 0.1 Ether if you're sending Ethereum. And if you're sending in Link, you could do, for example, the other function, which is using a cast send and then specifying the token. You're specifying, as you can see here at the bottom, the source contract for the programmable token transfers contract. And then you're also getting in, using that information to pull in the necessary details for the rest of the function that you're transacting on. The transfer address and then UINT. So you can see here, whenever you're using the transfer function, the ABI specifies that you transfer it to a particular contract address and in the amount that you're transferring it. I also have the RPC URL, and then whenever you use dash dash interactive, it's actually really super neat. Something I love about Cast is that it lets you access the ABI directly to execute a transaction by directly connecting to RPC. So you can directly interact with a blockchain through the command line interface, which is super duper neat. I would do it here, but the interactive part does ask for your private key. So to do that, I think it's just best for you to do that on your own and in a way that doesn't potentially accidentally expose those private keys. So if you do dash dash interactive, it's going to prompt you with enter your private key. Make sure there's no sleuths around you. Look over your shoulders, look behind you, and then go ahead and proceed with that. So what you'll also notice in the next section after you've got it and funded your sender and funded your programmable token contracts with these requirements is the scenarios that we're going to be producing. And those are those three scenarios with the token transfer, the sending of the message, and also the programmable token contract sending. So with the token contract sending, the way that we do this is we'll use the token transfer script. So with the token transfer script, you're able to specify a run function there. As you can see here, it says run and then it has uint and the uint8. And in the token transfer script, what it does, we'll pull that in here. What it does is allows for you to get the amount and the pay fees in. That's what's being specified. The amount is this amount, and then the pay fees in is this right here. So since we're paying fees in Link, this is going to be the 0, this is going to be the 1. And since we're sending one link, what it's going to be is 1 followed by 18 decimals, because of course, or 18 zeros, because of course we don't have any decimals in Solidity. So once you do that, you're able to go ahead and use that transaction. And we have scenario 1 here. And you'll see the transfer fee specified. The status of the CCIP message can be tracked here using this link that will pop up there. And it'll tell you that message ID, which you can just pass into that Explorer. So it's super neat. Chainlink allows for you to follow along with what is happening whenever you submit your transaction so that you're able to securely submit your transaction and monitor what happens whenever you submit that transaction so you can be responsible for whether or not that transaction was carried out. And if it's not, sometimes it'll allow for you to do some sort of manual overrides so that you can do those transactions on your own, which is also super neat. So after you've sent over your transaction and you're able to successfully transfer your tokens, then you're able to move on to the next section, which is the second use case, which is allowing for you to do the sending of the messages, which is also super neat. So whenever you're sending your message, you're going to want to look at the scenario that's there in the README. And the README has a few subpoints under there. The first subpoint is looking at the transfer token. So it's very similar, but slightly different. You're doing a CCIP token transfer, which is once again using the run functionality. It's specifying the amount, which is in this case, CCIP's BNM. So you're going to want to send one CCIP BNM from mode Sepolia to Ethereum Sepolia, and you're going to pay the CCIP fees. In this case, it's going to be paid out in Link. So it'll say the message script that you're going to be using, and it'll say CCIP token transfer. So let's look at that here. Let me exit out of this. So here in the message, CCIP, we have run and pay fees in. But since we're going to be sending a message. We have send message, we have the message, and the pay fees in. So those are two things that you're passing into here. And then also what you'll have is the destination chain ID, which we just have here manually coded in here, the message receiver address and the message sender address. Whenever you deploy those contracts, you're going to want to add those contracts into the environment variables, and that will allow for you to access them whenever you're doing this right here. So take note of the note that says this is the deployed contract, because you need that in order to proceed with the step of sending the message. And what it does here is it uses the basic message sender. Like we saw earlier, there's a basic message sender contract that allows for you to tap into the send functionality. So you can see here, there is a destination chain selector that's passed in the receiver, as well as the pay fees in, and the return is the message ID. So you'll get that message ID, and it's going to look something like this whenever you submit it. So it will say the message ID right here, just like you discussed. And it'll also give you some logs, such as in my case, I used the token to send address. I just notated that for my own personal notation. And then it also gives you that CCIP monitoring link there. And whenever you go there, you can use the message ID so that you're able to track the success or lack thereof whenever you submit that transaction. So that is something that is super neat. So while this transaction is confirming on the CCIP network, we can move on to the next step in the scenario two, which is doing a cross-chain message. So transfer over tokens, that being those testnet tokens, and now we're going to send over a cross-chain message. So whenever we do that, we can send over whatever arbitrary information that we want to send there. I recall how I said that arbitrary message or arbitrary data just means a message, basically. So in our case, we're going to go ahead and use the message of hello world. And you can use forward script and then use that message script once again. You're going to send a message this time. And again, you have that SIG functionality where it says --SIG, which is going to allow for us to tap into the run function, which allows for you to pass in a string. In our case, that string being the message and that message being hello world, which is a very classic way of doing this. And the hello world is also going to be tied to the second element of the send message, which is a 0. So let's look at what that is. If we don't know what send message 0 is, we can go here and then pay fees in. That's going to be 0. And then 0 will be the basic message sender pays fees in. There's 0, and then there's also 1. So 0 is native, 1 is link. So if you want to know how those work, you can always just navigate over to the source contract and figure that out. And that's an example of how you can do so. Whenever you do that, it's going to look a little bit like this, the transaction. I've already done it for you. It's going to, again, give you that sort of the message ID. It's also going to tell you some information about the transaction. I include there in the transaction as well as the chain ID so that you're able to keep track of the fact that you're doing the right chain for the right transaction. It's a very important step. If you get it mixed up, then it will normally throw an error, but sometimes it won't. So you got to keep track of that. Give the success hash, the block, as well as the amount that you pay for it. It'll indicate if it was successfully transacted. And then you can go and look at the transaction hash, and you can look at the block explorer, and you can see how that transaction has been executed. Now, the next step that you'll be doing is the get details part. So 2C is the getting details. So you get the details once the CCIP message is actually finalized on the destination blockchain. And you can see the details in the latest message by using our get latest message details script contract. So this is also contained in the message script. So get latest details. So get latest message details is once again script and helper. So what you have here is the message receiver address this time, the receiver. And what we're doing there is we're actually using that message receiver to get the latest message details, and it has that information console logged. So let's see what that looks like. So here we have it executed, get latest message details, and it has those elements there. So I'm going to try to do it again. Let's see what it says. Okay, so this is what it looks like whenever you're doing this live. Takes a second. All right. So as you see before, whenever I originally did it, I had submitted that very early on because I just transacted it. So it didn't have that information quite yet. So what you're going to need to do is going to need to wait a little bit to make sure that that message was actually successfully passed through. And then only after it's actually been successfully passed through, you're able, of course, to access that data. Because if you haven't yet submitted it successfully, then the data, there's no details to be gotten. And it'll look like this. So if you do see this at first, don't worry. It just means you got to wait a little bit, check out that transaction hash and make sure that everything's aligned. Then once it is successful, you'll see here, hello world. And it's very exciting to see that message there. Now that is the 2C part. There's a cast functionality that happens with the last element, and that is the withdrawal token. So as we discussed before, remember it's withdrawable. So with the withdrawable tokens, the basic message sender is actually also able to withdraw the assets that you submitted into the contract for paying out of those fees. So you'll use the cast send command to get those tokens out of that contract. You'll use the withdrawal function that's inherent in the withdrawable contracts. And if it is a token, you'll be able to if it is a token, you'll be able to do withdrawal token. If it is a native asset, you could do the withdrawal and pass it on to the receiver of that native asset, which is what is here. So if you're confused about what any of these addresses are here at any given time, once again, you can just highlight it like this. I do Command D on the Mac, and then it'll take me here to basic message sender so I can see, okay, oh, that's what this is, the basic message sender. And any of these scripts here say that. So whenever you deploy your contracts, make sure that you do update your scripts so that you're able to do the cast and etc. And you're sending it over to contracts that do not belong to me, but instead belong to you. That's a very important thing to do. So hopefully you remember to do that, because I'm not going to be able to always refund everybody if they send it to the wrong place. Fortunately, these are testnet tokens anyway, so you can always get more. So the last scenario is the program tokens scenario. So um, before we get into the programs token scenario, take a deep breath, make sure that you are understanding everything. If you are watching this replay, go ahead and rewind things and look over any aspect that you might have not fully understood. And we're going to dive into it now. So once you're ready, you can unpause
Um,
it and press play, and we can get into the third scenario, which is programmable tokens. I
Hey,
hear an
Valentina. Yes, that's me interrupting you because I love the breather. I'm here to breathe. Take a second to just intake everything that
I love
we've
breathing
seen
too.
just now. Yes,
Drink
it's great.
water.
It's drink water, stay hydrated. Please, everyone, go find some water. I know this was a lot of information, but it's super clear, and I love this repo. So, like, uh, just pay attention here. That's a great thing. You can watch the whole thing, just get a comprehensive understanding of how everything works on a higher level, and then just go fork the repo and start playing with it. So I love this. This is great resources that you're sharing, and also we've shared the link to the Chainlink faucets as well. Now that we
Thank you.
have some air, we drank some water, you can go on now. Great.
Awesome. Okay. So now we got some air and we drank some water or whatever else that you drink. We have the third scenario. So I'm excited to work through this third scenario with you. So our final scenario is involving the programmable tokens. And these enable you to send and receive tokens that contain code that is executed upon delivery. So at this point, you should have a sender contract on the source blockchain and the destination blockchain as well. You'll have a receiver contract. So this is just the same thing. It's the programmable tokens contract, but you're just deploying it on both sides. So whenever, again, going into the deploy contract or deploy script here, whenever you're running that under the hood, what it's doing is it's deploying the token sender, it's deploying the message sender, the message receiver, the programmable token sender, as well as the programmable tokens receiver. And here you can see in the token sender, for example, it's a sender, right? So since it's a sender, you're going to be using an RPC URL of mode Sepolia, because our source chain is mode Sepolia. Our destination chain, which is where we use our receivers, is on Ethereum Sepolia. So if you need to like organize these, change the script names, do whatever you need to do so that it makes some sense to you, I just did this so that it's clear what your sort of options are. But if you just want to do them all at once, you could do ER and deploy, and it'll do all of those amazing things for you all at once. And similarly, you could also write in those sort of those other elements where you're using a other aspect of the script. And if you're specifying the function here, you're gonna have to want to use these escapes here. Otherwise, it's gonna look like that, which is not good. It's bad news bears. And here we have like the drips, the transfers, those sorts of things. We're using that SIG to pass in that information. So let's go back to the third scenario. Third scenario consists of an A and a B. We have the sending of the message once again, and we also have the getting token details. So using our program script, what we're going to do is we are going to execute commands that enable us to send and receive and get details from the latest CCIP message that's received. And that's all contained within the program script. So let's look at the program script that's over here. And if you're looking at the tree over here, we have script. It's going to be over here, program, and close that. So we have a bigger screen here. So the program, we're going to look at the first send tokens and data. All right, so send tokens and data, it's looking like it's going to be a run function, a string, address, and a uint. So let's figure out what that means. Go to program, send tokens and data. Cool, check mark. We have message, token, and amount. That's what our string, address, and uint are. So what's the message? The message is the information that we're going to be passing on to the other blockchain. Recall that we have many messages that we can add in there, but in our case, we're going to be adding hello world once again, this time through a programmable token transfer. And we have a token, and this token is going to be the token address that we pass in here, which is a 5. So if you're confused what that is, as am I. Here it is. It's 3, 2, F5. All right, that's the BNM address. So that's the source BNM address, which is why, of course, you're going to have to use the command earlier so that you're able to load up the receiver contract with that BNM as well. So whenever executing that script, you can use the BNM address, and then we're going to do the amount, and that's the amount that we specify here, and that's 100. So that's, of course, an 18 decimals, so it says 100, but it's actually 100 units. So it's going to be much smaller than just one whole unit of the token itself. And whenever you do that, it'll allow for you to do what is shown here, which is sending over that transaction, and it will do a hello world. You're seeing there. It will be able to be monitored by passing in that message ID. It tells you the chain ID, the gas price, all that other information, and it lets you know where it's completely fully executed. So that is it for the third scenario. And what I'm going to do here lastly is I'm going to work through a very neat functionality that we have. I'm very excited that we have this rolled out, and it makes life a lot easier whenever it comes to your testing environment, because you're actually able to take advantage of CCIP's technology without having to actually deploy to any blockchain network explicitly, but you can do it implicitly or you could do it locally. And by implicit and locally, I mean to say like implicitly by forking the actual network, and you're not actually broadcasting it to the network, but you're forking the network and you're using the forking functionality for the local CCIP to fork a blockchain and do a thing. So let's see what we're doing here. So we have a base fork test, which is just using here the CCIP local simulator fork. Sorry, those pop-ups keep coming up. CCIP local simulator fork, which is very neat functionality because again, you can have a fork, and we have a destination fork and a source fork. In our case, we have the destination fork of Ethereum Spolia, source fork of Spolia, and then we have the source RPC URL, etc. So we're just setting up that sort of local environment. That's all you really need. The RPC URLs, and then you use that information to path into your creation of the CCIP local simulator fork. And then once you do that, then you can get information. Like I said before, many times, you're going to get the network details, you're going to get the destination chain details, the source chain details as well. And once you get all that information, in this example, just set up a base fork test. And I like to do these sort of base tests so that we can then inherit that base test information into our test contracts so that our test contracts aren't so front loaded and aren't redundant. So it allows for us to have less redundancy there. And then all we have to do is do a setup function, which is what's always called whenever you're running these functions for Foundry. And we're going to be using the base fork test dot setup. And we're able to do that because we claim, we label fork test as a base fork test. So whenever we do that setup, it does all that execution that happened in that other contract. So it'll prepare the scenario next, which is just getting that information that we need for by sending out by preparing the balances, the token, and the amount sent. It's going to give us some drip to Alice. So Alice gets some of that drip drop. And then we have the tokens to send details. And that's taken from the client that we specified with the details that we passed into there. And the first test that we have here is we're doing a test transfer EOA to EOA, and the fees are paid out in Link. And that gets the pre-balances, and you'll see how that looks. And then it'll also get the post balances after that information is sent out. It'll request Link from the faucet. It will also get the fees from the source router, and it will get the source link token, and it will approve it so that it's able to use the CCIP send on the source router. And it will then look at some assertions. So where it says assert EQ, that just means assert equal, which means that you can perform some sort of calculation on one side or the other side to make sure that it is actually sensical. So in this case, we have like the balance of Alice after, which, as you might have predicted, since Alice is sending tokens, we're going to get the balance of Alice before Alice sent tokens, take away the amount that Alice sent, and that should equal the balance that Alice has afterwards. Likewise, balance of Bob afterwards, since Bob is the recipient, we're going to add on from Bob's before balance the amount that is sent over to Bob. So let's do yarn test. You'll also notice that whenever we do this, it's going to do the test for the no fork option as well. And you can see here with the sender and receiver, it's just giving us some information on what happened before and after. So the before state for the sender here, sender is sending 1, so it should be 0. The receiver is sending, should be starting at 0, is getting 1. And then we have vice versa. Here we have Alice 1 sending 1, so it goes to 0, and then 0 to 1. Look at this programmable token program test. So we have the balance of the receiver after. Some error there. So find that error, and then you'll be happy camper. Here it goes. We found it. It's this. So it should be before, right? So I just repeated the same thing twice. That's why it says the same thing twice. That'll be updated there, but that's why it says that the one we could verify that. Balance of receiver. I misspelled it. The magic of live coding. Actually doing some live coding here. All right, so that looks better, right? So we have the sender and the receiver. Sender is losing 1, receiver is getting 1. Alice here is the sender. Alice is losing 1. The receiver is receiving. Might have guessed that. So the receiver gets 1. And that's what happens whenever you're passing in that level of sensitivity that I referred to earlier, the VV. So the dash VV is just how specific you want the test output to be. You can make it really, really specific and get a lot of details if you do VVV, 4 Vs. But we're going to limit it a little bit there. And it's going to take a second to do the fork testing, but it's computing that right now. So we have the message receiver test, the message sender test, and the programmable token transfer tests. And those are all done on the no fork side. And now we have here are the test suites for the fork side. So the fork side, we have that EOA to EOA fees in Link. And it shows you that they're successfully sent over that link. And that's good news. And then we also have the output for the EOA fees in native. And it shows you there, Bob is getting some, Alice is losing some. And that's the output for that as well. I will show you one last thing before I go. It's going to be this test with a even more level of sensitivity. So if you really want to get into the nitty gritty, this is very exciting to do. You get a lot of information whenever you do it this way. And this information will allow for you to see if there's anything broken anywhere along the way. It'll turn red and it'll say like, hey, look, this is where we failed. So if it's like getting the balance of, for example, and it's red here, that means, okay, we need to go back and we need to look at and see what is it about the balance of function that we're doing wrong so that we're able to fix that and be able to successfully implement the functionality. It also will show you any information that's being passed into any of the functions. So that's what you see there in the brackets. Or in the parentheses, so like if it's being an approval contract, or for example, or function, for example, it'll show you the amount, the address that's being approved for and the amount that's being approved. And it will show you the event that's also being emitted. So you can see all this very exciting things. That's why one of the many reasons why I love Foundry lets you have that level of specificity if your heart so desires, which mine does. So that's it. That's all I have for you today. There's a bunch of different ways for you to use this information. So let's just go over what we did today and just review how we can use this information to replay these scenarios and make them best for yourself, and work for your particular use case, whatever that might be. So we started off with an overview of how Chainlink CCIP works, and we showed how you can perform actions that can connect Mode Sepolia to Ethereum Sepolia, both of these testnet blockchain networks. We can also do this, of course, with the main nets, but make sure that you're ready for that before you get into the big league. So after reviewing that CCIP architecture, we applied 3 different scenarios that perform the core functionality that's inherent in that CCIP Chainlink product. Namely, that is those 3 different scenarios that we reviewed: the ability to transfer tokens, the ability to send arbitrary messages, which is like data that you're sending over like hello world, and the ability to perform programmable token transfers. And then we deployed these contracts together. We funded them. We gave them those testnet tokens, the ability to pay for those fees that need to be paid out to CCIP whenever they're transacting, either sending or receiving. And some of the key functions that help with facilitating the cross-chain interactions seamlessly from one chain to another. We were able to do all that together. So challenge yourself now to use the information and the knowledge that you just acquired to try out your own use cases. So before we go, just make sure you give this video a like, follow this channel, of course, YouTube's for Chainlink's YouTube channel, where we also have tutorials, workshops, and master classes that are readily available. I've done quite a few. We have other developer relations engineers that are really great at this, been doing it even longer than me. This is like my 5th month here, so very excited to be able to present all this information to you. And if you have any feedback from me, I'd love to hear from it. If you want to connect or ask me any questions, my socials can be found at 0xbuns.com. That's 0 with like the number X and then buns.com. And thank you just again so much for joining me. Thank you for sharing your time here. You could be anywhere, but you're here today. And I'm very glad that we're able to review Chainlink's CCIP on Mode. And I hope that y'all enjoyed this as much as I did. And also, thank you so much, Mode, for having me here as well.
Wow, you not just gave a masterclass on CCIP. That was an amazing outro and a lot of information as well. I love all the resources that Chainlink has out there, educational resources. It's super complete and there's a lot of information out there for builders. I love this. This was great. I do have a question from one of the recent hackers at the Super Hack, and that is, let's say there's a blockchain that has CCIP, but it doesn't have the chaining oracles in the new chain. For example, there's a lot of new layer 2s. I think that can be the case, right? Where there's a route for CCIP, but there's no Chainlink oracles. How feasible or how secure it is to bring Oracle price feeds from one chain to another using CCIP, for example? Like, can you use CCIP to message the result of an Oracle price feed on one chain and bring it to another?
I don't know how often that happens. Do they have an example of where that ever happened, like where we don't have price feeds, but we do have CCIP?
Let me see if the person is online, because I don't know if there's an example of that. So probably there's no chains where there is CCIP, but there's no Chainlink oracles. There's no case like that.
Okay.
Maybe not.
So
Okay.
the only hesitation that I have with that personally
Mhm.
is just that there is a delay. So it depends on just like how important and urgent that information is. Um,
Right.
so it wouldn't be the best practice to do. What would probably be better in that instance might be using something like using the functions, for example, which will give you instantaneous results. And the functions will be able to call a API or like interact with the API and like
Mm.
multiple APIs that I use, for example, that like use RPC to connect to blockchain information. So that API can actually be pointing to a API that's set up looking at a price feed and using that as a reference. So that would be a better option to do. But ultimately, the best option would be to use to give us the feedback so that we can make sure that we have the price feeds there, so that you don't have to do these convoluted workarounds. But functions also is
Yep.
another option. Just make sure that you have a reliable source for that truth.
That's perfect. That's perfect. And I love that you're super open to people reaching out to you. So please do, any builders that watch this in the future, the recordings, just reach out, ask your questions, ask if you want a feed somewhere and they don't have it, if you want Chainlink somewhere else and it's not there yet, just communicate with the team, let them know this. If you find anything useful from their socials, their content, or this workshop, share it on your socials, share it with friends, and just spread the word. This was
I also
awesome,
shared
Valentina.
the link
Yeah,
that you mentioned, in
yeah,
the private chat if you wanna put that in chat, 'cause I don't think I could do that. Okay.
perfect. Yeah,
And that way
let's do
people
that.
can go to my website and they can see, top left corner, there's a button where all of my socials.
Awesome. Yeah, you can see it down there, 0xbonds.com. Um, that's awesome. That's awesome. Yeah, so this was great. You even demonstrated live coding and some debugging live, which was great to see. So these things happen all the time. This is a live stream workshop for all of you with Chainlink, knowing how to use now CCIP to the fullest. And this is great. This is great for hackathons. Just in 1 hour, you can get all the content there. You have an amazing repo to fork and use it with all the examples there. You have the Chainlink faucets, and you have the contact here of Valentina. So, Valentina, we're on the hour mark. So, to be mindful of everyone's time, just thank you so much for this. This was great. We've learned so much. And yeah, hope to have you again around. And let's hope we have other hackathons that we can share and see amazing products for getting built.
Yeah, definitely. I look forward to working with you all again in the future, and I appreciate you having me.
Awesome. Thank you so much. And goodbye, everyone.
Bye.